you're welcome to Science Spectrum with Don. Welcome to Chemistry 189, its fundamentals. Alright, this would be the fifth part of the first lecture, and it will be a continuation from the previous lecture where we discussed the physical states of matter, specifically for a solid substance. Now we go to a liquid substance. Now I need to make a quick recap. In solid substances, their particles, they cling rigidly to one another, right? That's the first thing. And the force of attraction that exists between those particles of a solid substance is strongest. So it gives the solid a definite volume and a definite shape. And of course, a solid substance could be either crystalline, its atom could have well-ordered arrangements, well-ordered geometric arrangements, or it may not, and that we'll call an amorphous solid substance. Now, let's go to a liquid substance, right? Now, what makes a liquid is simply the closeness of its particles or molecules, so to speak. Now, for a liquid substance, the particles or molecules that constitutes a liquid substance sticks firmly, not rigidly now. So the particles, specifically molecules in a liquid substance, in a liquid sticks firmly. So this simply means that the force of attraction that exists between the particles of a liquid is weaker. So the force of attraction between the molecules of a liquid, of a liquid substance is weaker, yet strong enough. So yes, the force is strong enough to give it a definite volume, yet strong enough to give it a defined or a definite or fixed volume. Alright, now I may need to draw how the molecules or particles of a liquid substance, okay, how they are spaced in between one another. So this is a molecule of a liquid substance. This is a molecule, cluster of two or more atoms. We could have another, right? Cluster of two or more atoms is a molecule, and we could have another. Now, it may interest you to note the space in between them, right? Unlike the space in a solid substance. Alright, so this is, I may need to change this color code. This is, alright, be the same. Alright, now, it may interest you to see, right, how far apart the molecules in a liquid substance are, right? So effectively, we could say they touch each other, right? Effectively, they touch each other. So they stick firmly, right? And the force of attraction is a weaker force, yet strong enough to give a liquid substance a definite volume. And because of this space in between them, they are mobile, they are free to move. So it gives a liquid substance now the fluid nature, right? It gives it its fluidity. And because of that fluidity, we'll say, but the definite volume, but a liquid substance has an indefinite shape. Okay? Because of its fluidity. Fluidity there implies it can flow, okay? it could flow. So this is for liquid substance. Now, when we talk about the compressibility of the particles, okay, of a liquid substance, so the compressibility of particles of a liquid substance, or just say of a liquid, okay, when compared to a solid. Now, solid is very slightly, but for a liquid, okay, we just use the word slightly. Now, this is for a liquid, right? Now we move on to the third physical states of matter, which is, okay, the gaseous states of matter. All right, we need to build this for a while, so I could wipe this off. All right, now we go to the gaseous states of matter. The gaseous states of matter, which is the third part, or the third physical states of matter, alongside the solid and the liquid. So we go to the gaseous states. So this is gas. This is gas. This is gas. Right? Now, the difference between a solid, a liquid, and the gaseous state of matter is simply how spaced their particles are to one another, right? So we'd say the particles of a gaseous substance, okay, are very far apart. What this simply means is the particles that makes up a gaseous substance, okay, they've gained enough energy, okay, so to speak, kinetic energy, such that, okay, they move independent, okay, of one another. So they are very far apart. Therefore, the particles, their particles move independent of one another. Alright, and it may interest you to know that the force of attraction, or the force that binds the particles of a gaseous substance together, is weak. So a weak force, okay, exists between the particles, okay, of a gaseous substance, All right. So this also implies that, okay, a gas is also called fluid. Fluid implies it can flow. It could flow, right? So I may need to draw, okay, the particles of a gaseous substance now, okay, and we compare how far apart, okay, they are relative to a solid and a liquid substance. All right. So based on the fact that a weak force exists between the particles, okay, we could say they are very far apart, okay? So you could get one with a particle here and another there, you get one here and another there. So they are very far apart. So a weak force binds them together because they've gained enough energy, okay? And of course, they move independent of one another. So this is a gaseous substance. Now, because the force is so weak, right, that the particles of a gaseous substance move independent of one another, right? It means a gaseous substance, okay, has an indefinite volume. So it has an indefinite volume and shape. So take any gaseous substance, right? It will always take the shape of its container, right? And of course, it could expand to any appreciable extent, okay, when heated up. So the volume, right, is not really a fixed volume. All right, now when we talk about the compressibility of the particles of a gas, clearly we see how far apart they are to one another, right? So it means when we talk about compressibility, it is high in gases. So the compressibility of particles that constitutes a gaseous substance, is high. It implies, right? I could bring this, okay, when I apply pressure, right? I could bring this, okay, to one another. Now, there is always a force. Since each of these particles, right, they've gained enough energy and they move independent of one another, they always exert a force, okay, to one another and to the walls of their container. So this force that is exerted to one another and to the walls of their container, we call that the pressure. So far so good, right? We've talked about the physical states of matter, which for one is the solid state, okay, alongside the liquid state of matter, and of course the gaseous state of matter. So we could call, okay, for simplicity's sake, we could say a liquid and a gas, okay, they are both regarded as fluids, okay. So both gas and liquid, okay, are fluids. Okay, fluids implies they can flow. All right. Now, this is the first classification, right, of matter. That in terms of its physical state. Now we move on now to classification of matter in terms of the kind of atoms, right, or molecules or ions in that matter. Now we call that based on its composition. So we switch to, you need to do this for a while. So the classification of matter now, the second classification of matter based on its composition. So this is based on, okay, its composition. This is the second classification of matter, okay? So the composition here implies the kinds of atoms, okay? The kind of particles that makes up, okay, matter. All right. And of course, when we go with based on its composition there implies, okay, composition, okay, is the kind of particles, okay, the kind of elementary particles, the kind of elementary entities, okay, okay, which could be atoms, molecules, okay, and ions. All right, I may need to wrap it up here for the sake of time, but when we define how the composition of matter, okay, we are talking about elements, okay, talking about compounds, and of course we talk about, okay, mixtures. All right, I need to wrap it up here for the sake of time and YouTube's policy. This, okay, would come to a grinding halt here. If you're new to the channel, you want to like, share, and subscribe for more content. Thank you.